Hi, welcome back to another episode of Real-World Serverless, a podcast where I speak with real-world practitioners and get their stories from the trenches. Today, I'm joined by Ran Isenberg, who is a principal software architect at the CyberArk, and he's also an AWS Serverless Hero as well. And he runs a blog at ranthebuilder.cloud, where he shares a lot of his learnings from building serverless applications at the CyberArk. Hey, Ran, good to have you on the show.
Hi, thanks for inviting me.
Yeah, I've been reading quite a few of your blog posts in the past, so it's good to finally kind of meet you, virtually at least. CyberArk is a large company that's in the cybersecurity space. I did some consulting work with them a while back, and I know I think they started with some serverless framework stuff, and then they moved to CDK, and sounds like they've been quite enjoying CDK. So I've got some questions about that. Before we get into the CDK and testing and stuff like that, do you want to spend a moment and two just explaining to the audience who you are, what you do, and what does CyberArk do?
Okay, so I'm a principal software architect, like you've mentioned, at the platform engineering group, and my job is basically to enable other teams at CyberArk to do serverless properly, to reduce the cognitive load and help them build SaaS applications. That's like in a nutshell, but there's plenty more of that, to be honest. CyberArk was founded in 1999, and we have over 2,800 employees, 8,000 plus customers, and we started back in the day with on-premise solutions on the domain of privileged access management, on-premise solutions, like I said, and we've made the change in recent years into identity security domain, and we've become a SaaS provider. And that's pretty much when the platform engineering started to really develop at CyberArk, because we understood that it's really hard, basically, to build a SaaS application. When our first teams they started to build their SaaS applications, they realized that they need to solve many challenges. They don't really have to do anything with the business domain, right? They need to know how to deploy to the cloud, how to build their CI/CD pipeline, how to do observability, how to do testing, tenant isolations, many complex issues that are not really related to the business domain. And they solved these issues. And like I said, we had multiple teams doing it at the same time. So you'd expect that there'd be different solutions, in some cases, even completely different tech stacks. So that's not ideal for the organization as a whole. And if I need to take a look at perspective of the different personas at the organization, for the developers, there was no unified developer experience of how to approach SaaS, because some services, they chose serverless, some chose Kubernetes, some Python, some Java. And for the SREs, since there was no unified observability solution, they needed to learn multiple observability solutions, right? Each product had its own solution. And from the customer experience, there was no unified experience for all the products, right? There was no unified tenant onboarding experience, no even unified UI where you can jump around between applications. So that's why we started the platform engineering group, to basically provide a unified experience for all these personas, and again, reduce the cognitive load and help them focus on the business itself. That's the long story.
Yeah, so platform engineering is quite interesting because it's been quite a big, buzzword. There's been a lot of debate about what does it mean, and how do you define what goes into the platform versus not. And also, I've seen some mistakes other companies have made around the platform engineering, whereby the platform team kind of just builds in a silo, and sometimes they build things that the application developers don't actually want to use, or create frictions in the processes because they don't understand what is actual requirement from the application feature team. How does the CyberArk structure the platform team in terms of where does the platform start and where it ends, and how do you make sure that the tooling that you're building actually matches what the application developers want? How do you get that feedback loop?
Okay. That's a lot of questions. Okay. So we have, I think we do it a bit differently at CyberArk because we have both internal customers and external customers. The internal are the development teams, the SREs, like I've mentioned, even the sales team because they use our tenant management service. And the external customers are basically the paying customers of CyberArk, right? We have external services like shared services for authentication, audit services, even the UI itself and the login mechanism. That's a shared service, so to speak. So it has its challenges. For the external services, we get the requirements for the product teams, and they need to gather the requirements from all the services and to understand what's all our customers, the external customers that they require. For the internal customers, that's more of a challenge, to be honest. Usually, I mean, back when it started, it wasn't a silo. I think our managers did an amazing job to realize that you can't really develop in a silo. So very quickly, part of the platform engineering team, we split into like another minor group, and they built a new serverless service on top of the platform. So we got a short feedback loop, right? We got constant feedback on what we're doing and how our actual services are going to build up. Now, we started the platform group with the idea of using serverless services and CDK and Python. That's like the tech stack. And all the new services basically, well, now we're the golden path. So every new service starts like that, serverless first, unless they have a good reason not to use Python or serverless. It depends on their requirements. But back then, we needed to prove ourselves, right? So feedback loop all the time, like you publish a new SDK, you get feedback. Even during the requirement stage, I remember that when we started to build even the SDKs for logging and observability, we needed to get even correlation IDs, things like that. We need to get, I actually asked, we have a forum of architects, each architect from the different product, and we ask for feedback. Hey, this is our idea of requirements that we understand. Let us know if we're missing something. And they added more requirements, and they even changed my design at some point and made it better. Once we implement it, again, we ask people, hey, here's the new SDK. We actually advocate where we see ourselves as open source, like internal open source. So we have release version, release notes per version, and GitHub pages where we explain how to use the SDKs, things like that. So we tell them, hey, there's a new version. Let us know what you think about it. What can we do better? And they can even contribute code to make fixes or changes, so we're not a bottleneck at some point.
Okay, that makes a lot of sense. That kind of like an internal source model with like a custom SDK. That's very similar to what we actually did. What I did in my previous company at the Zone, where we had similar thing. We have a platform team. We know that we built a lot of the sort of common tooling. That's actually where I did the whole the first version of Lambda Power Tools, which I think Haito really liked that idea and actually took that and developed the AWS Lambda Power Tools from based on that idea of having like a common set of utility tools that you use. And I can see from your blog that you've written about that a few times, how to use the Lambda Power Tools in Python to do things like idempotency and error handling and things like that. I noticed that you've got a session coming up at reInvent with actually with Haito, OPN 305.
Yeah.
Can you tell us a bit about that? Because that sounds like quite interesting session.
Yeah. So the title is the Pragmatic Serverless Python Developer. So it's very specific for Python and serverless. The idea is to show you a very opinionated version of how you can build serverless, a serverless service, like a proper, we're actually building a proper service with a lot of code. It has a synchronous part, an API gateway and Lambdas and a database and also a streaming part. And we're showing you how to build it, how to all across different pillars, right? You have project structure, you have how to write your handler, how to write your CI/CD, how to write your domain code, your integration layer, how to do testing, basically all the things that you need to do to write a proper a service, including idempotency, logging, observability, things like that. So we're going to use Power Tools a lot, but yeah, it basically should help you to start a serverless service. We provide the GitHub repository, and we also provide a template, which we used. It's a template that I created on my GitHub. It's called the AWS Lambda Handler Cookbook, where you can basically start a new serverless service in a click with all the best practices and CI/CD pipeline and all the things that I've mentioned. But it's a skeleton. It's not like a full-blown service.
Yeah, I wish AWS would do more opinionated sort of content like this, because one of the things that I think I struggle, but also I'm sure lots of other people struggle as well. It's just that the sheer amount of content you get from AWS, but none of it are opinionated enough, so that there's a lot of choices to choose from, but you're not really sure which one you should choose and how to combine them. Whereas like opinionated sort of view just give you, hey, here's how you do everything. I think that's actually that's great, and that's what a lot of people are looking for.
Yeah, I agree. Instead of telling you, hey, you should do tenant isolation, you should do observability or things like that, we actually show you, hey, this is how it works, this is how we can get it done.
Yeah, like try and test the approach that that's been used within other companies. I think that's always good to see. So that's OPN 305 session for anyone who's looking for it, and you'll find a link to the reInvent session catalog in the description below, so you can look for the session and go and see Heiter and Ran talk about building serverless applications in Python using the Python Power Tools. So you mentioned testing there. Certainly, there's something that I'm very interested in. I've done a whole course on that, and it's something that I talk about a lot. I'm really curious about your approach towards testing for your serverless applications. I imagine you have, say, a lot of Lambda functions, but do you also do things like using direct integrations, from API Gateway or AppSync or EventBridge? How do you tackle those kind of problems, when it comes to testing?
We're gonna talk about it also in the session. So, okay, so we use CDK, but to be honest, it doesn't really matter. But in the end, we use CDK, so we have some extra special CDK specific tests. I know you're not a big fan of those, but I promise you that I have a good reason, and they're very, very accurate. So we're gonna get there. So the idea for me as a developer is that I don't want to leave the IDE. I want to work in the IDE, do everything in the IDE. I want fast, repeatable tests, and I want to have as much as confidence that my code is going to run on the cloud the same way that it runs on my IDE. And the way I can achieve, to run my Lambda function in the IDE is very simple. I have several layers, like a testing pyramid. The names might be different between companies. It's a different definition, but I think the ideas are the same. So I have unit tests, which everybody has. For me, since I use Pydantic for schema validation and input validation, things like that, the unit tests are usually specifically, they cover a lot of schema validations, because we usually write like very complex validations. We really add like custom validators and more complicated schemas. So it's important to have those tested to make sure that you're covered. And then you can also test very specific layers, like models, very specific models, very specific functions that you want to mock. Make sure that input A goes in, input out, input B goes out, output B goes out. So this is very specific. Then you have the integration layer, which is basically most of the tests are going to be there. The integration are run post-deployment. And why is that? Because I want to use AWS resources. I want to use real resources. Our developers usually, we all use the same account, but we have different stacks. So your stack might have a prefix per developer. So we can all work on the same service and have like our own virtual environment, like our own stack and virtual service, whatever. We use our own resources at the same account. So the way we do it is we generate the event data that I want to test, like the input that I want to test for my Lambda function. It can be behind an SQS, or it can be behind an API gateway or whatever. And I use PyTest, I call the function in DE, and I can debug it. And I can choose whenever I have a call to AWS API, I can choose whether to mock it or not. So the happy path would just use real services with real responses, and I can really debug it properly. And then you have the edge cases. I want to see that if I fail to put the item into DynamoDB, I want to see that I can catch the exception properly, and my handler returns the internal server error or whatever I want to return. So that's where I use mocks. I don't like to use Moto, if you're familiar with it. I use it only in very specific cases where it's really hard to generate the use case that I'm trying to go for. For example, I'm going to use an API for list organization. I want to list all the accounts there, and I want to have an organization with 2,000 accounts. That's really hard to do like a real API call, right? So that's where Moto is really good. And that's the only use case that I'd use it, because we did found some bugs where Moto didn't replicate the API call properly, like 100%. It wasn't the same response that you're going to get from the service. And if you use Moto, then you can't really use, if you use Moto with one service, you can't really use the other services with Moto. It kind of encapsulates everything, and everything's going to get mocked, which is not what I'm going for. So that's from the integration side of things. Does it make sense?
Yeah, it's actually exactly what I do. The approach you're talking about is exactly what I do. What I nowadays call remote code testing, so that you execute your code locally, but you're talking to the remote services like the DynamoDB and things like that. Except for the sort of the failure paths or things that are really difficult to hit the real thing, and I'll use mocks for those. And like I said, I'll have unit tests for my domain logic, and then I guess we will have end-to-end tests as well. Once the whole thing is deployed, you test the whole thing end-to-end by calling API gateway or whatever is the entry point for your service. And I guess you've got the same thing as well, right?
Yeah, I see we're synced, but wait a second, we're gonna get out of sync in a second when I talk about CDK tests. Yeah, it makes total sense for the async part in end-to-end. I think the key is to trigger the entire event from start to end. And then it can get tricky because it really depends whether your async part has any side effects that you can really validate. And if not, we've had one approach, and we did only on the test accounts, not in production, where you can deploy, if you send an event bridge message or SNS message at the end of the flow, you can create a tester listener on the SNS, like an SQS that will listen and trigger a Lambda, and that Lambda will write to a download table or an SQS message. So you'd have some side effects. So you can see that it actually works. And then your PyTest will do some polling with a timeout and make sure that the end message gets to the SQS that you wanted, and the message looks like what you expect it to look like. It's not fun to write such code, but I think that's the best way to really see it works end-to-end properly.
Yeah, that's what I do as well. And for async tests, that has the side effects for things like one of the functions pushing something to event bridge, for example, and triggering some other people's code run. I tend to use ephemeral environment so that that doesn't happen. So I've got my own event bridge bus just for my stack. So for the feature I'm working on, so nobody else is going to be listening to my DynamoDB streams or mine, Event-Bridge
Exactly.
bus. That's how I kind of isolate the testing environments rather than try to use the mocks and things like that. Yeah, like the same as you, I like to hit the real thing, make sure that it actually works rather than just use the mocks. And, I've seen so many false positives because you never actually test the call to DynamoDB or to EventBridge or to whatever service. You're hitting a mock and you're telling the mock to say, okay, everything's good, but it's not because you got a syntax error or something in your code.
Yeah, I totally agree. Okay, so now for the part you're not gonna maybe not agree. So, and there's another layer. I call it the security tests, and it runs before the integration, before the deployment part. And this is where I synthesize my CDK into a CloudFormation template, and I can run all sorts of tests around it. I use usually CDK nag to make sure that I got everything covered. It basically looks for misconfigured buckets, like open buckets, or maybe you have an overly privileged role, or you misconfigured, you're not using, I think you can define your custom rules across the organization and share that, and then you can enforce like a security approach in CDK nag. We obviously have other tools, but it's a very easy tool to implement, so why not? You can see an example for that in the my AWS Lambda Handler Cookbook template. So I see that you're nodding, so I think that you're okay with that.
Oh yeah, absolutely. If you don't do CDK, you don't use the things like CDK nag, you end up using something like a cloud custodian or other things, or AWS config. Yeah, something to validate, make sure that you are following best practices when it comes to how you configure your resources. Either you do that before deploy or you do that post deploy. So it's something that you should be doing regardless.
Yeah, I think you shouldn't do it post deploy because then, well, it's too late. You have the security breach potentially. So
yeah. But the post deploy is in your like a lower environment, not in production.
Okay, got it. Okay, got it. Sure. That makes sense. Okay, so another test that now this is because it happened, right? It happened to us, so that's why we did it. We have tests for making sure that some resources exist, and sometimes that they have not changed their logical ID. And the reason I'm saying that is CDK, you can write code. Code can raise exceptions. Now, we had an issue where somebody wrote try except in the CDK code and they caught the exception. I have no idea why, but it's code and you can do it. So CDK raised an exception, some error that it had during the deployment, some validation, whatever. And the exception was ignored and it continued on and synthesized the CloudFormation template. And eventually what happened is that the critical resource was missing in our deployment, which is not good because then you're gonna potentially find out that when you have your tests, right? Or when a customer tries to access the code that uses that resource. So that's not ideal. And also if in other cases, if you move around resources from one construct to another, you're potentially changing their logical ID. And some developers are not really aware of that. That's very dangerous, especially when you're dealing with stateful resources like DynamoDB tables and things like that. So what will happen is that the table will get deleted, the original table will get deleted and reconstructed again. But this time it will be empty without all your precious data, which is not great. So these are kind of things that you should, I think, write a very specific pre-deployment CDK unit test, make sure that these stateful items exist and that their logical IDs do not change. And that's one option. Another option, if you don't want to write these code, you don't want to write these tests, is to use third-party tools like CDK diff. CDK diff, you can add it to your CI/CD pipeline, and it visualizes the changes that your CDK code in that PR are going to make. So you're going to see I'm going to delete the table and I'm going to build a new table. Now, it's not blocking the pull request, but it gives you visualization, so the code reviewer can understand if there's a potential risk in the pull request or not. So I think these are the two approaches. So you can either do I want to protect my code 100% and do the tests, or I'm going to do the best effort and depend that my engineers are going to notice that and use CDK diff.
Yeah, I guess I don't agree with that being the only two choices. I mean, one of the things that you mentioned there was if a stateful resource was missing, the only time when the customer, you find out is when the customer actually uses that. That tells me that you've got a big gap in your end-to-end testing, that your end-to-end test or other tests before that should have picked it up, especially if you're using remote code testing, because your local code be hitting those resources presumably. The other thing I guess you mentioned was the logical ID changing. So I guess I'm not 100% sure how you protected against that in the example you gave, because you were moving stuff around from different stacks. So the thing
you can assert that the logical ID is a constant that you put in the code and you make sure that it doesn't change, because you can override the logical ID if you really want for the resources the first time they're created, right? And then you have a constant.
Okay, but I thought you said that you were moving them between different stacks, or is that not the?
Not stacks, constructs.
Construct. Okay, construct. Okay,
yeah.
Okay. Sorry, missed that. Yeah. So in that case, you can also just can you not use things like the deletion policy to make sure that if that does kind of happen and people accidentally, change something, because it's not just the logical ID, but it's also other things that causes cloud formation to do a replacement. So DynamoDB, for example, if you accidentally change any of the schema configuration, it would you do a replacement. So you can also use the deletion policy to make sure that if that does happen, you're not going to just lose all of your existing data because.
Yeah, I agree. I mean, you have retained policies, you have backups in DynamoDB, and we actually use the backup for that case. But even if you have the retain, the application is still using, and the environment, if you pass the environment variable to the Lambda, it's still going to use the new DynamoDB table. I mean, your data is not going to get lost, which is great, but your application is still not going to access the old data. So that's not great. And I totally agree with what you said about code coverage. I think in an ideal world, you're going to have perfect tests and perfect code coverage, and that's not going to happen. But reality is that teams are not doing 100% coverage. And even if you have 100% coverage, it doesn't mean that you cover the 100% business use cases for coverages. So I mean, code coverage and business use cases are not always the same, and you have feature flags sometimes, and that really makes it even more difficult. So yeah, it's not ideal. I do have another idea. We do use another option that really helps to minimize the impact of such failures. Is we use code deploy, and we use canary deployments for Lambda functions. So in those Lambdas, with code deploy, you can define tests and really simulate whatever you want to simulate. And then if the Lambda uses that resource, if it's missing, it's going to fail. You're going to get a rollback. So that's great. So that's one approach, but it has its limits, and it really depends on, again, you're not going to do like a complete full-blown test there, but I think more sanity tests, because it's really complicated to write those tests. But again, it's like another layer of protection that you can add.
Yeah, but then if you can't trust your developers to write good tests and have a decent coverage for your normal application code, then you're going to really struggle to get them to write those kind of tests that you run as part of a code deploy, because it's, like I say, it's even harder to run those as part of deployment. And with code deploy, I also find that when it comes to isolating the errors, as far as I know, when you have at least that's what I tried last time when I tried to use code deploy. the metrics are not executed when using the Lambda weighted alias, assuming the metrics are not going to the exact version. The metrics are going to the alias. So you can't tell if when using the alias to say split the traffic like 10 and 90% to two different versions. If you see an error, you can't tell if it's coming from the new version or the old version.
Oh, okay.
That's what I observed when I tried to use code deploy with the Lambda weighted alias before. I don't know if they changed it because they only record one dimension, as far as I know, to the when you're hitting the when you're invoking a function to via an alias. So I find I found that okay, you can observe that there's like an increase or like a difference in terms of error percentage, but you can't quite isolate it to the version that you're looking for.
I don't know. To be honest, I haven't dug that deep into code deploy. I guess we didn't have a use case where it failed on the original, but usually when it failed on the new one. Like you have
that makes sense.
You have pre and post. So usually on the pre part it would fail. Yeah, but that's an interesting. I need to check that. So thanks for that.
Yeah. So it wasn't code deploy. It was more just the Lambda weighted alias and how you report metrics when it's invoked against the alias. At least when I was, I was trying to do this before with, with previous jobs. Okay, I was trying to find out. Okay, got an error there. Was it the new version or the old version? But I found okay, only get one metric, and it was the dimension was the alias rather than the version, the individual versions. And it was the same, I think, with the logs as well. The logs, the log stream shows you whether it's alias or version number. When you are using a weighted alias, the log stream also just shows the alias name rather than the specific version that was invoked. At least that was at the time. I don't know if they've changed that. It might be something that I have to go back and double check. But at the time, that's one of the things I thought. Okay, that's going to be tricky for me to figure out which error, which version the error occurred on. But like I said, if you can isolate that with pre and post, then maybe that's an easier way to identify those. But I guess because of how long how long you're going to keep an eye on that deployment, and how likely that those errors happen, whether it's happen straight away, they can catch in the pre, or does it happen one every 1,000 invocations, so that you probably don't see it until much later. And so I guess like CDK testing, it sounds like you're still mostly testing your logic, or do you do like snapshot testing as well? I think that's something that Matthew Bonnig and a few other people have told me that they do quite religiously, just in case something happens, like there's a breaking change in the CDK. I think Matthew uses the TypeScript CDK, and there was like a version 2.8, I think 80 or something like that. There was like a small breaking change, but it's not a major version increment. So he caught that when via his snapshot testing. Is that something that you also do as well, just in case there's some changes in the CDK package?
No, I mean we check the we have the security test and we have the logic end-to-end integration. I haven't encountered such a use case. Do you remember the use case? I mean, what?
Yeah, the use case
was the breaking
more
change?
I think what the particular use case or particular error that they caught was there was I think it was the ECS cluster configuration. There was one setting that was enabled by default before, and then and then after that particular version update, it changed from enable by default to disabled. So you have to explicitly opt in. And so, and for their deployment, they rely on that setting being enabled, and they were counting on the default behavior. And so they managed to catch that change via the snapshot testing. They basically essentially do like a diff so that they see, okay, in this deployment, that setting has changed, and so they managed to catch that via the snapshot testing. I think the rationale is Sorry, go on.
They had like a hidden assumption in the code, that's so to speak, right? Because they didn't specifically provide that parameter in the construct, but they just assumed that this is the default, that's okay for us. That's basically what you're saying.
Yeah, they didn't assume it was a documented default value, but unfortunately, they changed the CDK team changed the default value from one version to another. And I guess they're not really strictly following semantic versioning because that should have counted as a breaking change, but they don't really follow semantic versionings properly. So in that case, they only did that as a minor version update. And so the last thing I want to ask about, because you mentioned that you have like a custom SDK that makes developers life easier when it comes to doing things like tenant isolation and things like that. I want to just dive into that a little bit more and understand, what are some of the things that SDK gives you, and how do you, get tenant isolation in that case from using the SDK?
Okay, so the idea is basically to help the developers access resources of tenants. We usually advocate for the pool model for tenants. So in DynamoDB, it would be one table for all tenants, and people can make mistakes. They can in our lambdas, you always have the context of one tenant, but maybe you have a bug, maybe the lambda was warm and the context of the previous tenant was still active for some reason in the cache, whatever, and you use the previous tenant ID. Not good. You break tenant isolation. So we wanted to make sure that everybody uses the same library, that nobody needs to reinvent the wheel. It's used across the company. It's like very highly audited, security-related SDK. And we wanted to make sure that the dev experience is very simple and transparent. So essentially, you have the tenant ID somewhere. The tenant needs to be identified. So usually at the beginning of the Lambda, you will have another SDK for token validation to identify the JOT token of the tenant and extract the tenant ID, make sure that everything is okay. And what it does, it sets the tenant ID on the tenant isolation SDK. So now we know for sure this is the tenant ID for our session, for our context of the Lambda run. Now when they do whatever they need to do in the Lambda, in the logic layer, whatever, at some point they need to access resources in DynamoDB or whatever service they need, right? We support for multiple services in AWS. For each service, we did a different magic, I call it. But basically, I mean, it's not magic. I mean, we're using it. We based it on AWS articles, like proper IAM. We're not doing anything weird or custom, just wrapping some mechanisms around IAM. So the idea is that the Lambda by itself, its role it cannot access the database of the tenants. Nothing, cannot do anything. The only way it can, I mean, ideally, if the developers, they follow the rules and they use the SDK, because obviously I can't force them. But if they do that, the only way for them to get about a client or about a table or about a resource to get to the table is to use the SDK. And the SDK requires basically a role that it needs to assume. And the role can do whatever that Lambda needs to do for the table. It has no restrictions. So if it needs to get items, it can get all the items. If it needs to put the items, it can put any item to the table. Now, for this to work, the primary key of the DynamoDB table needs to be some sort of tenant ID. It needs to be somewhere in there, like a prefix, suffix, whatever, but it needs to be there. And then the way it works, the SDK does assumes the role, and injects an inline dynamic policy and inserts we use the row level mechanism of DynamoDB for the leading keys, if you're familiar with it. And we inject the tenant ID into there. And we know the tenant ID because it was initialized at the beginning of the context. And that way, you get a client. We return you back a client with those credentials that we get for the assume row. And that way, even if you try to get an item and put in the tenant ID, a tenant ID that is not the current tenant ID, you're going to get an exception, not from my SDK, but from IAM, from Boto, like in the client arrow. So it's very transparent and very simple. That's the main idea. And for each different service, we did a different inline policy that will match whatever we need to do. So basically, that's it. That's the magic.
Yeah, that makes sense. Because in that case, because the Lambda function's own IAM role doesn't have those permissions to access those tables and data, then you can also make sure that someone can't just forgot or someone don't realize that's how you access data in the CyberArk, and suddenly trying to you've got a function that has access to lots more things. But if you restrict everything through the SDK, then you have basically this access pattern baked into how your code has to behave in order to get access to your tenants' data. That makes a lot of sense, and I think that's something that we actually talked about back when I was doing some work with the CyberArk team. It's good to see that it's all in place now, and also you've got this whole library built around it.
I don't know if you remember, but I actually wrote that SDK, and I actually consulted with you back in the day.
Okay.
Yeah,
I don't remember. That was quite a few years ago.
Yeah, almost 4 years ago. So it's really surreal to be talking with you now on your podcast.
It's funny how things comes around. That's great to hear that things has been working really well for the last 4 years. So well done. I think that's all the questions that I've got. I have in mind. Is there anything else that you'd like to sort of mention? I guess is CyberArk hiring people? Because that's one thing that I hear from a lot of my readers and audience that they're looking for jobs where they can do serverless full time.
Yeah. We do hire. You can go to CyberArk. I think it's /careers and look for. We have worldwide offices, but we also recruit in Israel. That's where I'm from. And you can check out my website, Ran the Builder, where I talk about all these things. I think that's it pretty much.
Okay, cool. I will put the link to the careers page in the description below. It's careers.cyberark.com. So yeah, CyberArk team is it's got a really good team, and they're doing everything fully serverless. So if that's something that you're looking for, definitely check them out. And I can personally vouch that Ran has got some really good articles there on the Ran the Builder as well. And so yeah, thank you very much, Ran, for coming on the show today and to talk about and sharing your experience with at the CyberArk and doing CDK stuff. See, we didn't differ too much in terms of how we think about testing.
I think we're on the same page here. So
yeah, so that's good to know. But yeah, it's been a pleasure, and I hope to see you in person sometime at the reInvent, hopefully.
Yeah, we will. Yeah, good. I had a lot of fun, so thanks for inviting me.
Thank you. Take care. Okay, bye-bye.
Bye.